Hello and welcome back to another video. We're going to be continuing on with the TypeScript line 75 and we're going to be doing number of 1 bits. And this is similar to the problem we did last time, only it's easier. So essentially, you just want to get the number of 1 bits in a number. And so if you read, in some languages like Java, there is no unsigned integer type. In this case, the input will be given as a signed integer type. It should not affect your implementation as the integer's internal binary representation is the same, whether it is signed or unsigned, and so on. So essentially, you just want to return the number of 1 bits in a number. And this is pretty straightforward, and there's 2 simple ways of doing it. And there's also 2 simple ways of getting like both parts. So I'll kind of briefly go through those. So essentially, let's say you have a number like this, small number. You want to return the number of 1 bits. So the way this works is you want to get the number of 1 bits, but you can't really do that super fast, right? So what you want to do is you want to go 1 bit at a time. And how do we figure out if the last bit is a 1? And there's 2 ways of doing that, right? So if the last bit is a 1, you can either mod it by 2, because if the last bit is a 1, it means it's an odd number. So if it's an odd number, you can just mod it by 2. Like that would be fine. It technically, no, actually, yeah, that's fine. So you just mod it by 2, and then it would give you a 1 if it's odd and a 0 if it's even, and then you can just add that to the result. That's one way. Another way is to AND it with 1. So if you actually AND a number with 1, like this is just a 1, and you AND here, bitwise AND, this would also give you a 1 if this bit was a 1, and it would give you a 0 if this bit was a 0, right? Because a bitwise AND, you need both of the numbers to be a 1 for a bitwise AND. So if this was a 0, it would be 0, 0, 0, 0, and so on. And if it was a 1, then it would give you 1 and a bunch of zeros. So those are 2 ways of doing that. So now that we know how to do that, we know how to like figure out if this is a 1, what do we do after that? And after that, it's pretty straightforward. There's also 2 things you could do. You could either shift this number to the right. Shifting this number to the right essentially deletes the rightmost bit and puts a 0 on the left side. Or, so by the way, when you shift in TypeScript, you want to use this shift. You want to use a logical shift, because if you shift like this, this will give you this for a 1-digit shift, right? It'll essentially just get rid of a 1 here, add a 0 here. That's bit shift. But if you do this kind of shift, which is an arithmetic shift, you're going to have something like, let's say you have a number like this, right? Let's say your whole number is like 1s, or it doesn't even matter if the whole number is 1s. What matters is the most significant bit. So if the leftmost bit is a 1 and you shift, what happens is you get rid of this bit, but the bit that gets added to the left is actually a copy of the leftmost bit. And so what would happen is you would add a 1, and then it would like basically keep going and going and going, and you can never, the goal is to keep getting rid of bits until the number is 0, but you can't really do that with an arithmetic shift. So you want to use a logical shift. Now there's another way, obviously, and that is this way. So let's say you have something like this. So what is equivalent to a bit shift in reality? So a bit shift is basically a divide by 2, and let's just kind of show you why that is. So this number is actually 1 plus 6, right? So it's 7. So this number is 7. So if you divide 7 by 2 and you actually floor divide, you would get 3. And so what's the representation of 3? Well, the representation of 3 is this, right? And then all zeros. So you can see how this is the same as shifting, and let's take an even number and do the same thing. Let's take like a number like 8. So 8 divided by 2 is 4, and what's the representation of 4 in binary? It's this. So it's the same thing as shifting this right 1 bit. So you can either shift right or divide by 2, and essentially you just check if the rightmost bit is 1. If it is, you add 1 to the result, and then you shift the number to the right or divide by 2, and you keep doing that until your number is 0 because you have no more 1 bits left, right? So that's going to be kind of the algorithm, pretty straightforward, and now I can code it up. And we are going to be doing, I guess we'll do the bit shifting this time. So we can make a result, and then we can just say like while n is non-zero, result plus equals n and 1. We can AND it with 1, and we can shift it as well, right? So we just want to shift it 1 bit to the right. We want to use this 3 shift thing because this is a logical shift. Yeah, and then if you're not sure how your shift works in your language, instead of doing this like and shift, and works pretty much the same in every language, but instead of doing the shift, you can just divide by 2. That should work in every language, I'm pretty sure. At least it works in Python and TypeScript. Yeah, so let's try that. Oh, I forgot, actually, we need to return the result, right? So let's minimize this, full screen, submit. And you can see this does work, and this is as efficient as it gets. So in theory, bit shifting should be faster than dividing, but I don't know if that's true in TypeScript or just the way these problems are made. Like, it's hard to say. Like, I guess we can look, right? So this is 60% or 60 ms. So let's try actually doing this thing with a divide now and modding. So this is going to be mod by 2. And instead of bit shifting, let's do, just to really show you quickly, math.floor, like I said, and over 2. This should also work. And let's see if this is faster or slower. But this is essentially the 2 ways of doing it. In theory, bit shifting should be faster. I guess they're pretty close here, so maybe this is like pretty fast as well. But this is as good as you get for this problem. It just gives you like all kinds of different results the more you run it, so whatever. Anyway, let's go through the time and space for this one. So essentially, and let's actually go back to the bit shift solution because I feel like that one is, maybe some people don't know that, so that's the one I will show or upload and link the code for and stuff. So let's go through the time and space. So for the time, if you think about it, so how many operations can this be? And this is I think it's supposed to be like a 32-bit number, but whatever the case is. Yeah, so it's a binary string of length 32. And so technically this could be faster, but worst case scenario is essentially going to be, well, I guess it's just going to be like the number of bits in the string, right? Because essentially what happens is, or in the number, essentially what happens is every time you bit shift, you divide by 2. And so let's say the number is a 32-bit number. That would take 32 times. But as far as like being if you just think about like how big is a 32-bit number, in order to get rid of all the bits in a number, it would actually be a logarithmic operation because you're essentially dividing by 2 every time, right? So you're figuring out like 2 to the what power equals this number essentially, which is a logarithmic operation. So it would actually be log n, where n is like the actual number, not the binary representation. But if you want to talk in terms of how many bits are in it, then it would be n, where n is the number of bits. But if it's the actual number it represents, it would be log n. Okay. And for the space, we just have this result, so that's O1. We don't have anything else. Yeah, I think that's going to do it for this problem. Hopefully you liked it. And if you did, please like the video and subscribe to the channel. And I'll see you in the next TypeScript video probably tomorrow. So thanks for watching.